For the Clismaban project, we are evaluating how banana reacts to drought periods and how we can solve the issues, the current and the future issues of climate change and lack of water with biodiversity. So we are checking how to spread the risk for farmers by introducing more diversity in their fields. And so some varieties will cope better with certain conditions than others.
So we are one of the partners of the Clismaban project, and in this project we want to evaluate the resilience of banana production under future climatic conditions. Here we are in the Ecotron facilities of the university. It's a chamber where we can simulate any current or future climate. Here is the Ecotron infrastructure. You will see it's 3 stairs that are devoted to this growth chamber. On the first one here, you have the lysimeter with all the soil, and you see that the soil is present on several meters. It's a big amount of soil to reproduce what's actually occurring in field. Within this part, there is also plenty of measures that have carried out. We measure the humidity, the water content. We will measure also in our experiment the soil content in oligo-elements. And after this first stair, we have the second stair, where there is this climatic chambers, where the plants are grown, where our banana are grown currently. This is where we control everything in terms of CO2, ozone, relative humidity, temperature, and so on. And this control is done every 5 minutes, which means we can really reproduce a real climate. And at the end, you have all the technical space there. In order to be able to control everything there, we need a lot of technology upstairs to be able to push, for example, to pulse the CO2 in the room to simulate the future climate and to regulate all these elements of the environment. For the Clismaban project, we decided to spot on a specific place in Tanzania, which is studied by our colleagues from the KU Leuven, Sébastien Carpentier and Clara Gambart. So we have used the data that they have to make the current climate, the climate that has been tested here, and to compare it to the future climate that is expected according to a scenario in this same location.
Here behind me, you can see our banana collection. The colleagues have done a great job in collecting all this valuable diversity and in maintaining it, sending it around the world if there is demand for it. And it's the task of our team to basically characterize this diversity. If we are honest, the majority of the varieties, we don't know on what goal we are sitting. We don't know what ideal traits they have. And so we go in here, we wake up the individual varieties, and we simulate different climates to see the current and the future climates. And so we are basically looking in this collection here to pinpoint out which variety is ideal for a certain climate to grow. So for the Clismaban project, we are simulating the climate of East African highlands. The problem there is that it's higher altitudes in the tropics, so the temperatures are a bit too cold for most of the banana varieties. So what we are doing is that in our banana tainer, we are simulating different climate conditions, and we are testing which varieties can cope with those relatively low temperatures. The second problem in the East African highlands is droughts. So they have two dry seasons, a long one of 3 months, a shorter one of 1.5 to 2 months, depending on the place. So in the next step for us is, of course, to simulate also this dry period and to see how the individual varieties deal with a lack of water. So it's a huge collection, more than 1,600 different varieties. So phenotyping is a lot of work. So where to start, how to choose? What we did is, of course, we started by going back to the local farmers, because every region has its preferred type of banana they want. And of course, we went to our collection. We have seen, okay, how many of those have we? And we have explored the variability within the same type of banana. And so we are basically, the output we want is that we can recommend the same variety they're used to eat, but one that is, let's say, future-proof, climate-smart. This collection here, we are hosted by the Catholic University of Leuven, and the collection is basically managed by Biodiversity International, now fused with CIAT. Everybody can freely access our collection. People need to do an official demand, and then our team goes to the collection, starts multiplying it, and will send around for free 5 plantlets of each variety.
So what I'm currently doing is I'm screening the banana collection for temperature and drought tolerance. What we measure with the pressure probes are the turgor pressure of the leaves. So in fact, the sensors measure the magnetic pressure, and the further the leaves are apart, the lower this pressure. So the lower the measurement, the higher the turgor pressure we measure. And so we can follow the whole pattern during the day, during the night, and also see how they react after several days of drought. So what we're doing in the greenhouse, we put the plants on balances so that we can evaluate the transpiration in function of the environment. So light, temperature, vapor pressure, diffusivity, and so on. Well, under field conditions, plants are exposed to different environments all at once. So it's more agricultural relevant and more practical, so that we are really sure that what we see here under controlled conditions is also true in the field. Within the Clismaban project, we brought some bananas from here to Uganda, to Kenya, and to Tenerife.
So, after the visit of Ecotron, we will introduce another aspect of Clismaban project, which is the role of microorganisms. And for this, we are here in the laboratory of phytopathology. It's important to know that plants can be helped by microbes for their growth, for their stress resistance. For the long-term objective of this project is really to use this microorganism to help the banana to resist to the drought stress that they may encounter in future climates. And this could be a very key element as some cultivars that are preferred by farmers but are not so resistant to drought could be supplemented with microbes in order to cope with the drought stress, which will allow to continue their cultivation according to the farmer's preference.
Here we have a good environment because the bananas grow very well. We are in the very best part of Tenerife Island for banana growing. Plus, it is a pretty dry area, so the water that the bananas receive are mostly the water that we apply, and that we can measure very easily with many mechanical devices. Actually, we have some sensors to see exactly the water that is on the ground at different depths. Well, in this field, we do different physiological measurements and also agronomic measures in order to know how the plant is managing all this water stress.
Clismaban project is focusing on introducing to the Kenyan farmers cooking banana hybrids that are high yielding and resistant to the major diseases.
I have been training men and women together in the boardroom. And when you are giving information to people, at that time they look at you as the information giver. So some of the issues that we are trying to discuss within the boardroom was decision making in the family. That's very important. That is core in gender training. Division of labor in the household, and also the distribution of resources within the household. Why do we come to the farm? As if that knowledge would not be had in the field. The reason we came to the farm is gender is not actually sometimes talkable. It is invisible.